Dear friends, welcome back to Data Analytics Talks. As I was exploring the PostgreSQL database, we have seen many features, but one important feature I would like to elaborate today is materialized view. I'm not sure you already have a lot of idea about the materialized view. Very good. If you don't have, let's explore something more about the materialized view. So look at this database. It's a Postgres database. It has materialized views and normal views. Of course, there are difference between materialized views and normal views. I also looked at the SQL Server Express edition, but I could not find the materialized view. So the question is the materialized view is only available with PostgreSQL? Why it's not available in SQL Server Express edition or any edition like Enterprise edition? I remember that this materialized view is available in Azure Synapse. You know Azure Synapse? Azure Synapse is the cloud data warehouse from Microsoft. And I also remember that this materialized view is available with Oracle. This is not available with MySQL. So as we work very much with the performance tunings of our reports, dashboards, this materialized view can really help boost your performance of your reports and dashboards. So let's explore what is this materialized view and how can I create a materialized view and what are the advantages and disadvantages of materialized view. Let's start. Welcome back. It's all about materialized view. So what's the materialized view? Materialized views are powerful tool to improve query performance. So if you look closely, the definition of materialized view, a materialized view is a duplicate data table created by combining data from multiple existing tables for faster data retrieval. It's very interesting. Why this is different from the normal view? The reason is a materialized view is a duplicate data table. It's a physical table, not a virtual table as we see in the normal view. It's created by combining data from multiple existing tables for faster data retrieval. So what happens is like whenever you are creating a materialized view, the data in the physical table is created and the data is loaded by default, and the data comes from different tables. As you see in this example, so we have two tables. We have an event table and we have a sales table. The event table contains all the event related data, and the sales table has all the tickets or the sales related data. So if I want to combine events and sales and bring a view, I can create a normal view and I can also create a materialized view. So when I create a materialized view, the difference is that it is going to create a duplicate data table, a physical data table, and populate the data, and that is going to help you retrieve the data as fast as possible. So that is what is meant by a materialized view. Now let's look at the benefits of a materialized view. The number one is speed. Why speed? With materialized view, you can query data directly from your new view instead of having to compute new information every time. It's already calculated and computed and stored in a physical table. Secondly, data storage simplicity. The materialized views allows you to consolidate complex query logic into one table. So it gives you the storage simplicity. Materialized view provide a consistent view of the data captured at a specific moment. Finally, improved access control. So you can use a materialized view to control who has access to specific data. So we have speed, data storage, simplicity, consistency, improved access control. So, looking at what are the use cases of materialized view, the first one I can tell you is a distribute filter data. So, if you need to distribute recent data across many locations, like for a remote workforce, materialized views can really help. And second one is analyze time series data. So, materialized views provide time-stamped snapshot of data set, so you can model information changes over time. Then you can store pre-computed aggregation of data like monthly, weekly summaries. So that means when you want to analyze time series data, materialized views are very efficient. Then we have a remote data interaction. So in a distributed database system, you can use materialized views to optimize queries involving data from remote servers. So rather than repeatedly fetching data from a remote source, you can fetch and store data in a local materialized view. So this reduces the need of network communication and improving performance. And finally, we can have the periodic batch processing. So the materialized views are helpful for situation where periodic batch processing is required. So the majorly distributed filter data, analyzed time series data, remote data interaction, and periodic batch processing. So very important aspect of materialized view. How do materialized view work? So it's very simple mechanism. Materialized views work by pre-computing and storing the result of a specific query as a physical table in the database. So the database performs the pre-computation at a regular intervals, or the users can trigger by specific events. In the administrators monitor the performance and the resource utilization of materialized views to ensure they continue meet their intended purpose. So we need to create materialized view and we should keep the materialized views updated. So we have different approaches for data refresh: full refresh, incremental refresh, and on demand refresh. So again, the technical variation in different systems. So we know PostgreSQL, we have the materialized view, and you have to manually refresh the materialized view. So recomputing the entire view. So you populate the materialized view with the data at exact moment you create it. Then in MySQL, there is no materialized view support. Then Oracle automatically refreshes the materialized view. And SQL Server, we don't have materialized view. Even in MongoDB, we don't have materialized views as it is. It has another mechanism of using aggregate functions to deliver a similar capability to materialized views. So, what is the difference between views and materialized view? The final and important question. So, in a relational database, a views is a temporary table created by transforming and combining the data across multiple tables. Whenever a user queries a view, the database engine dynamically computes the result by running the underlying query against the source tables. But in materialized view, on the other hand, stores the result of the specific query as a physical table in the database. So, however, the data in materialized view is not always up to date. We have to refresh it either as a job or as a manual action or a trigger. So, finally, so what are the challenges with materialized view? A materialized views are another database component to consider. You add another layer of complexity in terms of maintenance. Secondly, you have to create effective rules that trigger updates to ensure the materialized views remain beneficial. And finally, if you are going to use a materialized view, you need to set clear refresh rules and schedules. So, now how to create a materialized view? We have a command create materialized view. and we have a refresh command, and we have a drop materialized view commands. Okay, let me close this session by showing you the code for materialized view. So we have a command called create materialized view, and this is against a Postgres database. So we need a schema, we need the name of the materialized view, then then we have the join query. Okay, so we do all the computation and joins in the view itself. So here in this case, we have a DVD rental system. We have tables, a rental table, inventory table, film category table, and category table. So we group by the name, and we will find out the amount, payment amount, isn't it? So we have calculated the payment against the DVDs. So this materialized view is taking care of that calculation. And there is something called with data or with no data. When you say with no data, initially this won't be loading the data. So we will have to refresh the materialized view after we create the materialized view. So since it is a Postgres, we are again updating the ownership to a specific account. So create materialized view, then refresh materialized view, assign the view to a ownership. And we can similarly we have the command for dropping materialized view. Similarly, if you we can also create a materialized view by using the uh, materialized view wizard. So it will open a wizard. So my materialized view. Then what we need to do is we have to enter the code. Okay, so we need to enter the code. So for that, you have a definition, we have a code. In this case, we should write the code here. So for that, let me again copy the same code. I keep the code here. Probably we will change the name, create a demo. If there is any parameters, we can provide the parameters. If you want any security, you want any privileges, we can provide the privileges. I don't need to add any privilege. Let me close these. So once done, so we can see the automatically the script is generated, right? This view name is my materialized view. So I can simply save this. So there is some syntax error. What is the error? I think I should not write this code as it is. I will simply write this code alone. So let me go back, go to the code. Let me remove everything. Now I can go to the SQL. See, this has properly recreated um, the view definition. Okay, so I can save this. Now all works. Then I have created a materialized view. Thank you very much for watching this video. Please share your suggestions or feedbacks in the comments. Looking forward to have another video with a new topic very soon. Thank you.